Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
My name is Thijs. I'm a tech evangelist. I work at a company named Combo. We are a hosting company in Belgium, near Ghent. Aside from that, I'm also involved in the PHP Benelux user group. This is me and that guy over there doing the closing notes. Who has ever heard of PHP Benelux? Nice. I should take a picture of this. Someone should take a picture of this. Who has been at our conference? I would call that there's plenty of potential yet. We'll do announcements. It's not about the conference, it's about the talk. So if you want to tweet to me or get in touch with me, this is the Twitter handle. And as important, and I see a lot of speakers doing that, and the conference organizers invest lots of attention to that, join in. Please rate my talk. If you think it sucks, tell me, but tell me why it sucks. If it's good, well, I wouldn't mind getting some feedback either. So that being said, let's do this. Let's kick it off. And let's start with the typical one. It works on my computer. Who has ever said that? Who's a developer in here? Who has ever said that to his manager, product manager? Yes. So, in which context did you say that? So, you said that it works on my computer, but why did you get into that conversation? Anyone? Internet Explorer, all sorts of stuff. So, was there a problem? Did the website go down? Who built code that caused crashes or slow performance? Everyone did. Come on, don't lie. Don't be shy. Okay. Now, whose fault is this? I would say it's the internet's fault. I wouldn't call it, it could be his fault randomly, or his fault, or the blaming game. That's why there are two fingers pointing, not one. But in my humble opinion, it's the internet's fault. And why? Let's think of the early days of the internet, or the early days when we were on the internet. Who has been on the internet since, let's say, 97 or 96? What did we do on the internet? There's a mic here. This is going to be recorded. Say that again.
Porn.
Joshua says porn. And other stuff like chatting or just surfing to websites, random stuff. And the guys who started from there and who went into the industry, like in the beginning, it was just marketeers or advertisers saying, oh, like enough with the printing. Let's do the advertising on the internet. Let's get creative on the internet. And there are other people, like these front-end engineers, who said, oh, we can make shiny things. Like we can do animated GIFs and we like blink tags and marquees. We could all do that kind of stuff. So in the beginning, it was all functional. So it was about advertising. It was about making it look good. The people who did that weren't really qualified to do so because the internet was so young. There was no real education program where they could get into. So basically, according to me, it's the fault of all the suits and all the hipsters. That's why it all got skewed, why it all went so bad. But hey, here we are. We can do a better job. We are developers now. We're not. Who does front end here? Just to check. Who's a front end guy? Minor. So the majority is developers, right? Nod, yes, developers. Great. So you guys can make up for the faults of these kind of guys. So you can think about scalability. You can think about performance. You can think about security. So that's the goal of this talk, to evangelize, if I can say so, the best practices in performance and scalability from a developer point of view. And there are certain quotes I'm going to show here that I've gotten into. So for those who don't know me, I'm in a hosting company. I did tech support for 6.5 years and got some fairly interesting situations along the way. This is a very popular quote. Isn't hosting supposed to be a bulk product? People don't really think about infrastructure. They just say, it works on my computer. I'm going to toss the code over there using FTP or another protocol, and it should randomly work. Isn't hosting supposed to be a bulk product? And the answer is no. Another popular quote, well, the cloud will make my app scale. That's a very popular one, the cloud. So we had this customer calling me, my website is down, but wasn't it in the cloud? Wasn't it supposed to work? Anyone remember that spectacular Amazon downtown? Yep. Who remembers that? I giggled. Not because I'm officially a competitor of Amazon. No, it was a good thing. Because it proved that technology can go south horribly If you don't take it into account, you'll run into huge issues. Like the people who, like the decision makers always think, oh, the cloud, that's that magical thing in the skies with fairy tales and unicorns and rainbows. We all know, like, we are technical people. We all know that it's just a lie. But what we can do is prepare people to take the step from one server to multiple servers. And we'll get there eventually. Another quote, and I have a story about that, large campaign sites on shared hosting, why is that a problem? So I had this major web agency. I'm not going to disclose the name. That would be very unfair. And because this is recorded, this could bite me in the ass. So there was a big company, and they had to do a bannering ad for a Dutch energy supplier. And they said, well, we're going to have millions of hits. I'm going to put in all kinds of websites in the Benelux area. Well, let's just put it on shared hosting because it's cheap. So they did, and they uploaded via FTP, and everything went well, up until the point they actually got some hits. Our sysadmins noticed this, so the Nagios monitor started going nuts, and we said, oh, let's shut these guys down because they're compromising the situation. Because shared hosting is mainly about harmony on that one box. So the guy called in anger, why have you shut down my site? Why is it down? So we explained the situation, and all of a sudden, there wasn't money, like the money was flowing faster than you can imagine. Okay, we put out the biggest box, we put in multiple data centers, scaling technology, Varnish in front of it, and everything went well. But what was the problem there? That the person had no clue what was going on. The person responsible was a Flash developer. Touché. Another one, very popular things. I used to have this every month. Database index? What? What is that? So what happens is they call, hi Thijs, I'm calling you to say that your servers are massively slow. I look, they're a bit slower than they usually are, but that comes with a reason. When you do top on the Linux command prompt, you see MySQL D 99%, bam, bam, bam. So you log in, you do a show full process list, and you see all these weird kind of queries. You do an explain, and you get these million cardinality like rows. Everyone knows explain, right? Explain in MySQL. Huge amount of joins, left joins, correlated subqueries, bam. So what's a database index? If you get it wrong from the get-go, you're screwed. I have a couple more, not that much. I won't bore you. It's just to get started, right? It's the last session. Everyone is tired. We don't feel like doing much, right? So another popular one, we'll solve that with an Ajax call. That's a cool one. I hear that all the time. People have no clue what they're doing, and they're messing it up, and their timeouts are extremely low, and they're creating hits, and the server goes nuts, and they have absolutely no clue what they're doing. Why? Because they are creative people. They don't know the fundamentals about computer sciences. And I'm pretty sure you guys do know. And the final one, the very final one, and that is an important one. It's about numbers. So you have these marketeer types or these business developers who call and say, we're going to have a large-scale campaign. We're going to need hosting for that or infrastructure for that. And we'll probably have 10,000 visitors. What does that mean? 10,000 visitors what? On Drupal or Magento or on a static HTML file? And these 10,000 visitors, is it during a month, a day, per hour? So 10,000 doesn't mean anything. Even if they could say, we'll have 10,000 visitors between 9 a.m. and 12 a.m., it doesn't really mean anything, right? If it's Magento, if you don't do massively insane optimization, you're screwed either how. So the point I'm getting to is, you have to get the numbers right. You have to try, see what happens, and I think it's not always in terms of how many visitors they have. System calls is a good indicator. All that kind of stuff matters. So what are you going to do? Because we've warmed up. Like, we feel warmed up, right? We're ready to get a bit more in depth. If you get the numbers right, you could make certain decisions. But if you decide, or if you see that the code base is utter crap and you can't really do anything about it, what are you going to say? You're going to do a complete rewrite? We're developers. We like Bling. We like redoing code. We like choosing a better framework. So we'll probably say, yeah, let's redo it. Let's make it better. But then there's project managers, basically making sure everything goes well. And they'll say, well, we're not going to do a rewrite because we don't have the time. Neither do we have the money. And the point I'm trying to prove with this is that developer time costs more than just adding bits and pieces left on the right. Infrastructure is getting increasingly cheaper these days, so it might be a better choice in the short run to maybe scale it a bit infrastructure-wise. And that's what this talk is mainly about. So what do we do? So how are we going to solve this? We noticed that our app is really slow. It's our fault. We know how to fix it. We don't have the time. Neither do we have the budget to allocate a week to it. Well, I heard stories where people said, let's do absolutely nothing. Yeah, that sounds weird. I know there's a big telco who had a web application that wasn't performing really well. And the project manager said, we're going to release exactly that date. And the developer started crying, like 10 developers said, we can't do it. It's not done. It's not performing properly. Let's postpone it a week or two. And the project manager said, no, we're not going to do that. Like, how many people are going to be impacted? And the developer said, well, we expect 10 to 15,000 people who will be impacted. Oh, it's only 15,000. Let's do nothing. They won't notice. So some people actually do nothing as a strategy, but we're not that kind of people. We have pride in our work, and we want to offer the best solutions. And the first solution we're going to do is just throw random servers at the problem. On a short-term basis, it works. It really works. I know this story where we were having a party at the office, and we have our own dedicated bar. We're having drinks, playing ping pong, all this kind of stuff. And all of a sudden, one of our sysadmin comes, guys, you need to step in the office. There's something bad going on. So one of our clients had done a campaign for a really, really large customer. It was a web shop, and it scaled horribly. So we tried to figure it out, because they didn't have the time, nor the money, nor the budget, anything. They didn't have the resources to change anything, and they couldn't postpone it. It was going on. They had hundreds of thousands of visitors. And we had to figure out a way to do so. And the way we managed, and you're going to think it's ridiculous, but it makes sense. We couldn't add servers because they didn't have money to purchase servers. Neither did they have the time to wait for us to install the servers. So they said, well, let's make a load testing script. And if the load goes above a certain level, we're just going to change the doc route to a static HTML file saying, we're quite busy right now, bear with us, refresh, and you'll get your page. And he lost 50% of his hits. And you'll say, oof, the glass is half empty. 50% he lost? Ooh, it's horrible. But he won 50% because if we left the situation as is, he would have lost 100% of all of his visitors. So that was fairly successful, and I was very creative. That wasn't the best solution in the long run, but that resolved the situation that Friday night. We can also do some tricks, and in the end of this talk, we'll have plenty of tricks we could do. So if we talk about throwing servers at the problem, I'm not talking about actually doing it on multiple servers to start with. The simplest way of doing this is just adding RAM. We like the cool stuff. We like multiple servers. We like load balancing. We like clustering. We like all that kind of stuff. But if you want to do quick and dirty, you can add RAM. And RAM does a lot of things. Like if you have a decent server with a decent operating system, beg your pardon, installed, then it will work just fine. Just add RAM, 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 RAM. And you'll, like when working with cloud or virtual platforms, just clicking buttons. It works. So it's fast, it's cheap, but it is limited. You can only scale that much. And in the end, it's going to become a bit more expensive. We all know we're leading to, we're going to scale across multiple nodes, and that might be a challenge. Who has tried that before? Who has scaled apps across several nodes? Yeah, still a couple. How did that make you feel the first time you tried it? So. It's not quite porn, is it, Joshua? It is. So it is efficient. It is the most efficient way. Scaling across multiple nodes is the best way to do it. But it's very cumbersome. There's lots of considerations, and there's a big initial effort. If you have a customer who has an app that runs on a single server, he deploys it. It's simple. He takes FTP or SFTP as his age. He does it with source control. It doesn't really matter. And then he has to move it over to multiple servers. That's when the trouble starts. But the question we need to ask is, what kind of infrastructure do we need? And what we see is, do we need the one big box? Like you have these companies who invest huge amount of money in these big mainframe systems, and it all comes vertically. It's like a monolithical system that does everything. You can scale across 100 nodes, which comes with the necessary trouble. And I was at a certain conference, I think it was in London. A guy came up to me, and I had this question a lot of time. We have the big F5 load balancer. So what they spent a couple of Ks on the load balancer, and that didn't really help their situation. So we have the big F5 load balancer. How can that solve our troubles? Well, just sell it and get HA proxy. That was my advice. Like, makes sense. So you don't really need the big F5 to get stuff done. And you should investigate your traffic. If only your database server is getting hammered, you shouldn't invest in all the scalability up front. You should first solve the issue where the issue is. And we see lots of cases where we have event-driven websites, and then they hit the peak where everyone is going to the website. Let's say festival websites, we all know them, right? And up to that point, you investigate the traffic, and you see, oh, this is MySQL traffic. We should just add another MySQL server. Instead of starting off with Varnish and all the fancy stuff, add a bigger MySQL box. Make sure they move their database from the one server to the other. And it helps. It's a good way of doing things. You shouldn't over-engineer things. And we made sure they had 65,000 hits in a matter of a couple of hours. So investigate that thing and don't start scaling where it's not necessary. And if you have lots of static traffic, what would you guys do? Nginx proxy. Yes. Any other plans? Different server. Optimize that server. Any other ideas? Final one? Varnish could work as well. Yeah. Yeah, CDNs could work as well. And another very, very interesting point that I'm thinking about more and more and more is, what if in 99% of the cases shared hosting will do, and at 1%, maybe it represents a week, maybe it represents 2 weeks or a month, they get huge amounts of visits, they have huge amounts of load. What are we going to do? Because it's always difficult to migrate customers' websites, or for you guys, if you have to maintain someone else's code base and it has to be migrated to a different box, things could go wrong. I've done hundreds of migrations, and believe me, PHP is very flexible, and sometimes it's a bit too flexible. You have the INI settings, you have absolute paths they use, you have the connection strings you need to find. Some code is just compiled with ZendGuard, you can't look at anything. So it's not that easy. So I'm thinking about a strategy, and I know a lot of colleagues of mine in the industry have tried that semi-successfully. Instead of just moving it off from the box to a bigger set of dedicated machines, you just add nodes to it. And we'll get to it in the end. The point I'm getting to is you use Nginx with FPM or so, and you put the FPM PHP installation on separate boxes. And when you see the load increases, you just add extra boxes, and a box, and a box, and a box. And it's cheaper than setting up a dedicated cluster, redoing all the configuration work, migrating all the data. No, you just add a box, add it to the load balancing, and you're done. So shared hosting might still do, and it's a strategy we're planning to use in the near future. Okay, a couple of considerations about multi-server setups. That one is important. What do you need to take into account when you move it off one server into a second server? Who has got some interesting ideas about that? Sessions. How would you solve that? You should give this talk. You're giving all the right answers here. So yes, one thing you should do is take the sessions under consideration and move them off, possibly to a Memcached set of servers. Why is that? If you start load balancing and you use the file system as your default storage for sessions, it will work the first time. And if on the next hit, let's say you're logged into your shopping cart, you add products and you want to add another product and you hit it and it switches over to the next node, you lose your session storage, the cookie doesn't match, there is no session, you're logged out and you lost your product. That is not something you want to do. We still have people who save it in database, but I don't find that a very good idea. I find Memcached, as you considered here, the best solution. Why? Because session data isn't really infinite. It's pretty volatile. It comes in, it has an expiration time, so it's not really, it's crucial, but it's good that it can disappear as well. And that's what Memcached is for. It is a cache. It has a TTL, and the TTL in the source code of the Memcached code is exactly mapped to the GC max lifetime. So it's perfect for that. You had a remark there, sir? Because databases tend to be slow, and databases don't expire automatically. You have to take that under consideration. It has to be deleted. If you have huge amounts of session at the same time, and the indexing is not quite right, you'll run into trouble eventually. You don't really need to do that, whereas Memcached can have multiple nodes, and you can do replicas as well if you configure them right. And you just offload it, and it's in RAM, and it's way faster. Okay, you can create memory tables in MySQL, but that's just... Yeah, but that's just cutting corners, right? If you can have a solution that is tailored to do that, like, I could drive the highway with my bike, but my bike isn't really made for that, right? You can do all sorts of things. You can skew it into directions you want to, but you have to make the tool that is built for that, and out of the box, Memcached does a pretty good job doing that. And it distributes all the session data, and you don't have to take that under consideration. Another thing, so we covered sessions. That is cool. We covered sessions. What else have we got? Uploaded files. How are we going to solve that one? Shared storage. That's a good one. You have several things we do. You have sometimes you use local storage and you replicate the data using rsync or different technology. We sometimes use NetApp SANs, big ones that are very reliable because the user-generated content in terms of files is very important to them. If they lose them, it's a disaster. So you need enterprise-grade storage for that. That's a good one. You need load balancing as well. Anything else? Like user-generated content, you have files. What else have you got? You have database. What would you be implying?
Well, maybe cron jobs, which every server has to do.
You could set up a different cron setup if you want to, like have a separate management server that does all those sorts of things. That would be a good idea. So one point to manage, and then you could mount the file system or whatever you need and just do the actions on there. Let's say you have a Magento big setup and you want to do the indexing. Well, you're going to do that on a separate node. You're going to mount the files there and you're going to index your stuff there. That's a good practice, and you have tons of best practices for that. But from a database perspective, like replication, who has ever used master-slave setups or master-master setups? Again, the same question, how did that feel in the beginning, the first 5 minutes? Yes, the replication model in MySQL isn't that brilliant, but in the end we can make it work as long as we don't have too much connections in the master-slave setup. So we know it's a big effort, and you need to think of that in advance. So if anything I want you to remember of this talk, it's prepare that in advance. Make sure the code you're making could scale well. You could decouple bits. You can run it over several nodes. You have the sessions covered. You have the data covered. Everything that could be configuration intensive, you need to figure that out in advance. So our goal is when we run into these trouble, and your application is built for that, that you have to do, let's say zero coding would be ideal, only maybe some configuration management. And the number one tool we use when our systems are under attack is, of course, a caching system. What does caching do? Well, as you see on this image, it protects our nice little tree from the big, bad outside world of thunder and clouds. And cache, what kinds of cache do we have? We have several sorts of cache. So we have the front ends, the things we can cache. Yeah, pretty cool picture, isn't it? And we have the back end, the storage, where we can cache it too. So we have several things. I'm not going to ask the question because that's going to take so much time. We've reached half of this talk already. But what we have is we can do bytecode caching, ops code caching. Who does bytecode caching in his code? Maybe one question, what tool do you use? I'm hearing both here. I'm hearing Xcache and APC. I'm a fan of APC. Why? Because the community really, the PHP community really drives that. But I run into problems with APC as well when it's combined with Zend Optimizer. It doesn't play well, and some files are encoded with ZendGuard, so you need Zend Optimizer to decode them. So Xcache could be a worthy alternative. I'm sometimes seeing benchmarks using Xcache. I must admit, I haven't played that much with Xcache. APC is my preferred tool. Well, I'll have a look at it. Other things. Is it faster?
APC was a little bit faster, not much.
We'll see how APC evolves. There's lots of momentum, or more, let's call it more momentum in APC because the core people who make PHP are really supporting that. There are other things we can cache. Even with APC, we can cache other things because APC is actually also a backend, and it does ops code caching, and it has an interface you can use. You can do page caching. That's something all of us do, right? Page caching is the most trivial way. Another thing we could cache is data. And we'll get to that, like the intermediate level. Who caches data rather than just plain HTML output? My session is pretty obsolete. You guys know everything. So what are we going to cache? We know that we're going to cache pages, data, opcode. We could do browser caching as well. Why do we need to optimize the servers if we can avoid the hits coming to the servers? That's a good one as well. And when not to cache, and that's also a problem. Who has ever done caching where you had user-generated content and sessions? That got a bit tricky sometimes. Did you solve that with an AJAX call? A lot of people solve that with AJAX calls. And also, how long do you need to cache something? That's always the trick. Like, is it an hour? Is it 5 minutes? It's always hard to balance out. How long are we going to cache? And do we need to take the time to live into account, or are we just going to purge the cache actively? That's always a difficult thing. And if we're going to purge the cache actively and it's in a distributed model, how we're going to organize that we can clear up the cache, make sure it's consistent, and we don't get stampedes on the back end. So that's kind of difficult. And that is not something a operations guy like me could solve. This is something we have to solve together. And that's why DevOps, important word these days. Who has heard of DevOps? For those who haven't heard of it, apparently it's a Belgian invention. I'm pretty proud of it. Look it up, Google it, Wikipedia. It's about collaboration between the developer and the operations guy making it work. Like, you know the pointing finger? The developer says, well, it worked on my computer, and the sysadmin says, well, the Linux configuration is good. So we need to work together on that, and we need to make sure everything is compatible as well. If you choose Redis or Memcached, it needs to fit into your project. It needs to behave correctly. And there are tricks we can apply. Like the simplest of tricks I once do is use mod rewrite. Like we do a lot of shared hosting, or sometimes projects are on boxes you don't have lots of flexibility about. I use mod rewrite a lot. This is just a plain old Zen framework htaccess file. You just take you just check the files, and if it exists, well, serve it. If it doesn't exist, throw it to the index. And then you have, like, this is pretty stupid code. It's just to prove a point. I would never put this in production, so I'm not that bad of a developer, but it proves a point. So you require your database logic, which is db.php in this case. You get the content, like this is a stupid function, get the content based on the URI. You get the URI, you get the data, and you just fopen and write it to a file. That's it. And that could save your ass, literally. Okay, it's not that complicated, it's not that sophisticated, and I know us developers like the bling, but this is simple enough to make it work. We have people whose ass we saved with that kind of stuff. We can also use APC. We're not forced to use the file system. And this one comes with a nice little GUI. I love this one. If you install it via PECL, you don't really get it, but if you download the PECL package, you get an apc.php, you throw it on there, and you can see the hit rate. And there are several things you could do with that. So you see the different buttons. So you have the system cache entries. When you click that one, you'll see all the pages that are being served from cache. So what APC does, for those who don't know, it requests a file. And we all know that the compilation and the lexing and the indexing process of PHP is kind of slow. So you have the plain old source code. It gets lexed, it gets tokenized, it gets compiled, and then the machine code is being served to the system. If you have to do that over and over again, why not just take that machine code, store it in RAM, and reuse it? So upon the next hit, and the next hit is not really the page hit, but that file being used in the PHP runtime, then it's going to check the backend system, the RAM, it's going to see, do I have this machine code? Can I execute it directly? And it's going to give you an enormous boost in most cases. Well, you can monitor the boosting over system cache. You see the general stats here, but the point I'm trying to make is you can go to user cache as well. And user cache offers a clean API like APC add or APC save or store, whatever, and a fetching method. So you can write directly to RAM. And that is a very, very cool way of doing it. If you only have one box and you make it go fast, I would definitely prefer this over Memcached. Another really ugly trick, but I just wanted to throw it in, is using the auto-prepend and auto-append INI setting. Basically, we're going to just make a PHP sandwich. So we have so we have prepend and append. This will make sure, upon requesting a page, it will first run the append, then it will run your file. First the prepend, then your file, then append. And what we do in the prepend is we'll prepare caching, and in the end we'll close caching. And what we do here is, this is our little prepend file. So we request the method, and if it's a get, because we're only going to cache get, right? If it's a get, we're going to get all the information. We're going to fetch it from APC, directly from RAM. If it's in there, just echo it and stop, because we don't need to continue. We're going to cache. If it's not in there, we're going to open the output buffer, because we need to store everything in a variable. And we're going to run the script, and the script is going to do its logic, is going to output, and eventually it will reach the auto-append. And the append bit is going to check again, is it a get? We're going to get all the contents out of our output buffer. We're going to clean it, we're going to make a key out of it, we're going to store it in APC, we're going to output it, and upon the next hit, we reach the cache again. So this is a plain and simple system, a plain and simple way of doing page caching without actually touching any code in your logic. Okay, this is not bulletproof, but in simple cases, it could just work if you run out of time. Just register those two files in your INI, put the two files on the disk, and you're done. We can also do a caching layer on top of the database, and that's about data caching. There are other ways of doing this, like data is a pretty vague term, but I'm going to make a pretty simple example on, let's say you have an abstraction layer for the database, and you want to make sure it is cached. Okay, you can go to the MySQL, and you can increase the caching, the query cache. That will help you as well. But sometimes you want to control this from your logic. So let's say we have this little class. What it does is it has dependency injection, Stefan. It has dependency injection. And it injects a database component. Thank you. It injects a database component, and you fetch some data. Like you have a method that says, okay, I want to get this key, this thing out of the database. You do a select star or whatever, and you return it. And it works. But all of a sudden, you notice, like, this is really going slow. And I optimized my database. I added multiple nodes, but this is not taking me anywhere. I need to cache these row sets. So what you can do is take the same class, refactor it just a bit, because we're not going to throw everything overboard. We're going to just refactor it a tiny bit. You have your dependency injection. You save it. You have your same method. But instead of just reading it from the database, you're going to fetch it from APC again, do an MD5 on. You can give it a namespace so it doesn't clash with other systems. You get the key, and if it's in there, you're going to serve it from cache. If not, you're going to fetch it from the database. The only thing I did is rename the function, the original function, with an underscore to a private one, so it's not publicly accessible. And in the next page, you'll just have your storing logic and your original SQL statement. So what I'm trying to prove here is not that you should use this script, that you should think about using caching on a data level. Not only HTML needs to be cached, no. Data can be cached either way. And eventually we'll use Memcached as a storage system. Yes?
Never use select star because...
No, I know, but I was lazy in that. I know select name, dash, address, dash, company. I know, but I'm sometimes lazy. I do select star. I know it's my fault.
When you talk about caching, then don't use select star.
I admit. I'm wrong. I'm very sorry. We have Memcached. Who has ever used Memcached? Who likes it? It's good enough for me. We talked about session handling. So not only can you use the API to store data in a distributed way, you can also save your sessions automatically. So what you need to do is you need to set one up, decide what the key is going to be so it doesn't clash with other things, select a safe path, and that is just one or multiple nodes, and define a port, and eventually say, well, the handler is Memcached. And that's all you need to do. Okay, you need to set up the firewall correctly, but leave that to the pros or to the ops guys. So what else? What other tricks do we have? So we have Memcached, we have APC, we can use htaccess for caching. What else can we do? What other caches do we have?
For Memcached?
No, in general.
Oh, sorry.
I hear something interesting in the back. Indeed, reverse proxy caching. You put them in front of your web server, and I have props, and they should never give me props. I'm going to use it. So, in the majority of cases, you have your client system. I know you can't read this in the back, but I'm just going to use this. You have your client system. I'm going to try to draw it as big as possible. You have your client system, and you have your web server. And that's the way you usually communicate with them. But this is going to hit your backend pretty hard. If there's PHP installed, you have a MySQL behind this, this is going to hurt you. So what you might want to do is, it still behaves like a web server. It's not a web server. It could be a Varnish server, let's say. And your Varnish server is right in front of your actual web server. And whereas this one used to listen on port 80, you can make it listen to another port, port 8080. And this one is going to behave like your web server. Is it your web server? No, it is not. It's just going to the outside world, it's going to seem like a web server. And here you can have your PHP on it, and you can have a MySQL system on it, and it will work just fine. But this one is going to be your gatekeeper. This one is going to block all the requests there because it's going to serve it from cache. It's going to inspect the requests coming in because your client's going to think, oh, I'm talking to a nice little Apache or IIS or Nginx, whereas he's just talking to, let's say, a Varnish server. This one is going to inspect it. If he can get it from his RAM or his storage device, it's going to serve it directly here. So there's going to be communication back. And if he doesn't know the answer to the question, he'll just talk to the web server. The web server will respond back. He will save this in memory, and he'll serve it back. So that's plain and simple. And it's weird that we haven't been using it so long. Okay, in the old days we used Squid. Who has used Squid before? Who is still using Squid? Holy cow. Who uses Varnish? Nice. One thing these things do, and that's easy if you're a good developer, they honor your caching headers. And that is nice. So out of the box, if you are very disciplined about your cache control headers, your expires header, and what have you, these things are going to listen pretty nice. If not, we're going to do some tweaking. So Varnish is my tool of preference. And I haven't met anything that can outperform it yet. I have set it up on so I took the smallest VM I had. It was, I think, 512 megabytes of RAM. I installed WordPress, stock install. I installed mod PHP. I did a bit of MySQL. I threw it all on and started doing A/B performance testing up until the point I got 3.5 requests per second. That's what I had. So I started putting the Varnish in front of it, configuring it nicely, having a proper configuration file that matches the URL structure of WordPress. Guess the results. So we started out with 3.5. Guess the results. Guess wild. 1,650 that was. And I think that was the fault of my client because it couldn't send anything more, but the server wasn't doing anything. For those who don't know the flow of Varnish that well, this diagram might help. It's a cool diagram. So all requests from your client come here. And there are, I call this VCL regv. I haven't invented it. It's just a hook, a programmatical hook where you can dig into in your configuration file. And I'll show some config in just a minute. And this bit of software will say, I'm receiving this here. This is this request coming from this client. What can we do with it? Is it cacheable? Like if it would be a post request, it would say, this is not cacheable. If there's cookies involved, it would say, this is not cacheable. If it's not cacheable, it will fetch it from the backend and deliver it back to the response. If it is cacheable, it's going to make a hash out of the parameters it has, and it's going to check if it is in cache. If it is in cache, it will hit and will serve it. If it's not in cache, it will miss. Again, it will fetch it from the backend, deliver it, and we're good to go. Now, the storage medium for the hit or the miss, you can choose this. In the old Varnish setups, it used to be file, so you got it from file if you installed it via, let's say, apt-get. Nowadays, it's memory by default. It eats a lot of memory, so it eats what you give it, so be careful and make sure you have the right amount of memory you serve it. And it comes with a VCL file, as I call it, a Varnish configuration language file. And I have a config here of an existing site. So you register this on startup, so the system knows it has to look at this file. Usually it's defined in etc, Varnish, and the default one is called default.vcl. And it has a bit of config in this. The first thing we do, and you'll probably like this, for those who haven't played with this, it has curly brackets. So we're PHP developers, we know this. It has curly brackets. It makes us feel comfortable. We're not afraid. We're not crying. So there's a backend, and the backend we call it default because it's default. And you say, well, we're going to go to 8080, and for those who paid attention, this is 8080. This is our other server. It might as well be on port 80 of a different IP. It doesn't really matter. It depends on the setup you want. So this is where you're going to say, well, my backend is over there. And this is fairly cool as well. I put this in the beginning of my script too. We're going to define an access list, an ACL. And there is a number of hosts, IPs. You can add subnets to it. And this list is going to define who has the permission to empty my cache remotely. Because we want to put stuff in cache, but from time to time we're going to get stuff out of cache as well. So we're going to define who is entitled to do so. And we're going to start digging into our receiving bit. What's happening here? If it is a purge request, and mind you, this is not an official HTTP verb. This is just a trick that Varnish uses. You can use it via curl or other systems you have. You just mention purge, and you go to the URL, you replace get by purge, and it will evaluate this. Is this IP in our purge access list, so in this list? If it's not the case, it will say 405 not allowed by this IP. And it will look it up from the backend. It will go to the backend and see what happens if this is not the case. So if you hit this one, it will end and say, sorry, dude, no way you're emptying the cache. Because if you don't put a valid ACL on it and you have these creative guys like you and me, we're creative, right? And we start doing purging on random sites, we can make their server farm crash. So this is interesting. Now, if it's not a get, or not a head, or not a put, or not a post, not a trace, not options, or not delete, we're not talking about a valid HTTP verb, and we're just going to pipe. Pipe means we're going to bypass everything we have from the cache and directly send it to the backend server. The backend server has to do what it needs to do with it. If it is not a get or not a head, so it might be what, a put, a delete, or a post, we're not going to touch it because that usually implies that there's a change coming up or user-generated content. We're not going to touch it. We're not going to cache it. We are going to pass. That means we're going to pass on this one. This is the backend. Send the traffic over. And this is where it gets interesting. We're going to set up accepting coding in the right way because otherwise it uses this as well because as of Varnish 3, so we hit version 3 now, it could deal with compression. It can deal with gzip. It can deal with deflate. So we're trying to make sure it is in the right syntax, that it's either gzip or deflate, no other syntax. Otherwise, Varnish might get confused or have separate caches for it, might deal with it in a special way. So this is just optimization. So Varnish is more than a caching system. You can fiddle around with HTTP settings. So the next thing we're going to do is we're going to check all the extensions. So we're going to check if it's a GIF or a JPEG. So this implies static data. If it is static, as the word static implies, it's not going to change. So we're going to remove the cookies, and we're going to just replace all the excessive URL parameters coming with this, because if it's static data, it has no use. It doesn't make any sense to have extra data. We're going to just chop it off and just look it up in RAM. If there's Google-ish or other campaign stuff on it in the URL, we're going to trim it off. And if in the end our cookie is just a set of empty strings, if it's empty or multiple blank chars, we're going to just remove the cookies, because Varnish does not like cookies. If there's cookies involved, Varnish will say, I'm not caching this. So you can manually override that and get the cookie stuff out of there. So we covered that. So when the request comes in, we can fiddle about, remove some parameters, optimize some headers, and then we're ready to analyze it. And once it's analyzed and it has to fetch it from the back end, you can add some logic. You plainly see that this is a WordPress site we're optimizing. This is a VCL I use to optimize WordPress. So if it's WP login or admin, we pretty much know we don't want to cache this because this is our backend. This is the admin panel. So we're going to hit for pass. So we're going to say, well, we'll receive this, but this should not be cached anymore. And in the future, we don't want it to be cached either. So go directly to the backend. In other cases, so if it's not one of those, you just throw away the cookie because we don't want cookies, as mentioned. And if we cache it, we're going to cache it for 1 hour. Nothing more, nothing less. If it's a static piece of data, we're going to cache it for over a year. So we're very, very flexible in ways of dealing with this. And once we deliver it, and this is the last piece I'm going to mention about it, once you deliver it, just for debugging purposes, you can add an extra custom header, xcache, and you can say hit or miss. And for us developers, this is very convenient because we can use tools like Firebug and analyze in Firebug in the net tab if we got a hit or a miss. Once you're in production, you can remove this, but this is fairly convenient to know what's happening. Because if you hit it, are you actually certain it's cached, or is it new data coming from the back end? Because due to the expiration of it, you're not always sure what happens. So this helps you. And this final bit, the hit and the miss, we use this to actually purge the backend. In the new Varnish, there's a thing called banning as well. It's a bit more optimized, but I still like this. So we purge it, we remove the TTL, we say, okay, it worked out. You can add other information here. Look, if it was a hit and you purge it, you can say, well, it's been purged. If it was a miss and you purge it, you can say, well, it was never here. What you can do. So once we have that out of the way, we know that it will make your site bulletproof, but not all sites are very much compatible. Another thing we can do is optimize from a PHP point of view. So which PHP setups do you guys use? Who uses mod PHP to this day? I tend to use it from time to time. Those of you who didn't raise their hand, what do you guys use? FastCGI. Who's happy with FastCGI? I'm not that happy either with it. It's flexible, but it doesn't perform that well. And the problem with FastCGI is the system, and with the system I mean Apache and FastCGI forking the PHP processes, make sure that PHP has no clue how it was forked. So you have a process and another process and another process, and you might control it with suexec, and you might want to make sure that everyone has its own user for logging purposes. But they don't really know about each other, and if you have APC on it, there are going to be separate caches. So that might be cumbersome. So what I would like to propose, and who's seen Helgi's talk about Nginx? He talked about this as well, FPM. As an engineer, I really like FPM. I'm starting to like FPM as well. We still use for single server setups or for very static setups, things that aren't going to change that much. We still use mod PHP because it still outperforms fast CGI. When we want flexibility, we want to choose fast CGI. In the future, we're going to be all about this. So I have a bunch of configs of this. So whereas fast CGI just uses the mod FCGID or mod FCGI module of Apache, this one is going to come in a daemon. So PHP is no longer a library or no longer a binary, a CGI binary being executed. It's going to be a daemon. So you're going to start it up. It's going to listen on a port. You can communicate over sockets, and you can communicate over TCP/IP. And it comes with pools. So, okay, that was Yoni telling us we have 5 minutes to have fun, and then it's over. So I'm going to go a bit quicker. So FPM has a notion of pools, and each pool has its own configuration file, and you can mention all sorts of stuff. You can mention on which port it should listen, what the user is mapped to it. You can do all sorts of process management things. This was either in your fast CGI wrapper scripts or in your Apache. Well, this moved to PHP, so you can tune how many processes there are going to be, how they're going to respond, how many requests they're going to take. This is very, very impressive stuff. It's still early days. I think the project is going to mature in the future, but you should definitely, if you like, we're all developers, right? If you like bling bling stuff and you're interested somewhat in systems, try this. This is amazing. And what you can do here is use flags to do custom PHP INI settings. So you have your global PHP INI, and you can override certain settings per pool. And in the majority of cases, we're going to connect FPM to Nginx. Why is that? Because mod FCGID, the preferred fast CGI connector, can't play well with TCP/IP. It only works with wrapper scripts. The old library, mod fast CGI, isn't that well maintained anymore, but it does support that. So if I want to do it on Apache, I'm going to use mod fast CGI, but it's not really advised. So there comes Nginx into play. Nowadays, the #2 web server in the world. They skipped over IIS. Wasn't that hard. And it comes with really nice configuration files. This is a playground setup I made. This is not production. I just played around with it. It worked brilliantly. So there's a notion of upstreams, and upstreams is a collection of servers. For those who went to Helgi's talk, you'll pretty much know this. For those of you who haven't gone there, go see his slides. He has more detail about this. So I have 2 PHP servers. So you see where I'm going in these last 2 minutes? We're going to move away from having the web server and the PHP on the same box. So we're going to have boxes in the back end that'll have PHP running on it and nothing more than PHP. No web server. And they're going to be listening on port 9000. And we're going to have 2 Memcached servers we're going to put in front. And with in front, I mean in front of PHP. Not next to PHP, in front of it. It's also in an upstream. This is our virtual host configuration, and it has a root var dub. It has index files, it has a server name, and first of all, we're going to try the URI, then a slash, and otherwise we're going to just rewrite it to the index. We have a location called PHP. This is going to come in handy in the end. This is just a named block where you can have some CGI settings, and this is the important one. Fast CGI pass to FPM, and we defined FPM up there. So if we want to do something with PHP, we're going to redirect them to that named block called PHP, and that is going to fire the request off to a random server. Then, if the file, this is back to regular Nginx config, if the file would be a PHP file, what we're going to do is first we're going to look in Memcached. So you see we're going to reverse proxy a bit. We're going to check in our Memcached settings if we have it. And the Memcached key we're going to look on, that's the URI. So that's our unique identifier. If the request comes in, we're going to pass it to Memcached, and Memcached is a named block. For those who remember, those are sets of servers. It's going to go to Memcached and it's going to say, this is my URI key. Do you have something in store? If it has something, it'll just serve it. If not, here it is. If it's a 404, a 405, a 502, we're going to send it to PHP. And we know PHP, this is that. So we're going to fire it off to separate servers. Those are going to deal with it. We'll probably want to need Memcached again for the session clustering and so. It will return it back again, and Nginx will serve this. Why is this a scalable solution? Because we're going to scale from the back, not from the front. When we run into trouble with PHP or whatever, we're going to just add application nodes. We're not going to add web nodes, because the web nodes, the event-driven system of Nginx is that performant, that optimized, that you won't get into trouble for regular requests. It's going to be, the majority of the problems you're going to run into are back-end things. Waiting for MySQL, waiting for web services, doing complex logic. So that might scale well. Another thing, and let's not mention this too long, Cloudflare is also a solution for scaling. It's going to be also a sort of reverse proxy, but you're going to change your DNS records to them. They're going to do more. It's a commercial initiative, so they're going to do more than just caching. They're going to have DNS load balancing as well. We use this kind of tool at our office when we have like high priority websites. Let's say we have a site of the NATO we run, and sometimes hackers come along. There's some clans. They're fairly popular these days. They don't really have a name. They're anonymous, and they just try to attack. And they're going to try all sorts of interesting stuff. Well, if the traffic initially goes to them, you'll be safe, because they can do a lot. They're also a CDN, and who uses CDNs, who uses content delivery? For those who don't know, is just offloading all your content, and mostly it's static content. You can use it for dynamic. You're going to put it on separate servers. These are going to be like reverse proxies, but they have one cool feature. It's not going to be on one server they're going to store it. They're going to distribute it all over the world. So you'll have reduced risk because it's on several nodes. And it will listen to the main node. If something changes, it will sync back and distribute it internally. But the cool thing is, because it's distributed all over the world, it's geolocated as well. So if someone is closer to the States, it's going to serve it from a node that is in the States. If we're in Asia or Europe, it's going to serve it from nodes in Europe. So if you have lots of traffic, static traffic, coming all over the world, CDN will help you. This is not that super interesting. I'll be doing a dedicated talk on that at a WordPress user group. Optimizing WordPress. Like the basics is just install W3 Total Cache or the Varnish plugin, or maybe an Nginx plugin, and make sure Varnish is in front of it with the VCL I showed you, and just make sure the purging is right, because if you submit a new page or new post on your WordPress, it will just empty the cache. And mind you, WordPress is getting increasingly popular even for little sites. We see that a lot lately, more than Drupal these days. There's lots of Drupal for the bigger ones, but smaller campaign sites, people use a lot of WordPress. Magento, who likes Magento? I used to hate Magento, but now I like it a bit because I had these pro consultants coming over to our office explaining us how to tweak this. I'm going to show you in 10 seconds how to do so. This is the list of things we do. You can enable caching. You can go to your global configuration file, and you can use Memcached, or you can use APC to cache blocks of data. You're going to enable the cron, because that's going to make sure your database stays small, because it can generate gigabytes of log data you don't really need. So enable the cron. It will do a log rotation. That's very important. It's going to re-index as well. You want to have flat catalogs, because Magento is that flexible. It works with an EAV, entity attribute value. So everything is super configurable, and you're going to have a zillion joins. Well, they have a notion of flat catalogs. It will just save everything in smaller, maybe logical tables. Enable compilation, which is basically putting all of those huge amounts of classes in less files and modify the include path. That's what they're going to do. That's just click, click, click. Install the Varnish plugin. Varnish, again, to the rescue. Split front-end and back-end servers. The indexing server that I mentioned already earlier, put it on different nodes. And perform the indexing on that server. So point making here, like Drupal has similar things. The point I'm making here, it doesn't only apply to new software you've written. It also applies to software other communities have written and you're implementing. So think about that. There's a lot of resources on that on the internet. So we've reached the end of this presentation. Please don't be clueless. I beg you, on my knees, don't be clueless. Look these things up. Don't be afraid to ask for help. You can ask my help, but I know guys who are way better than me, so I'm going to redirect them. Those guys. So ask for help when in doubt, because we are developers. We care about code. We might care about systems too, but like true DevOps people are the assets you need. Ask for help to them. Apply the tricks I taught you, and you will be teaching yourself on the internet or while talking to people. Refactor afterwards, because that's important. You can make crappy code, put it live. Sysadmins will save your ass, but make sure you refactor it in the end when you have time and resources. And be happy. Please be happy. Thank you.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.